Okay, question 3. All 4 parts could be on the 2020 exam. No calculators allowed for these problems. Again, this is going to be an easy one for them to kind of use for this year because you don't know all the functions being put together. Actually, these ones you probably could figure out, but you could see something similar to this where it's ones you can't figure out. So it says that let f be the continuous function defined from -4 to 3, whose graph consisting of three line segments and a semicircle centered at the origin is given above. Let g be the function g of x equals the integral from 1 to x of f of t dt. So g is the antiderivative of our function f. That means that f is our derivative of our function g. So you just might want to keep that all in mind. And again, when you're taking your exam, write that down so you have that to reference for quick referencing, okay? So for part A, it says to find g of 2 and g of -2. So all we're going to do there is we're following what g equals. It's this, right? So that means that g of 2 equals the integral from 1 to 2 of f of t dt. And if you look here, from 1 to 2, what shape do we have? A triangle. So that's all we're doing. 1/2 base times height. Okay, what's the base of that triangle? 1. What is the height? You may need to calculate slope of this segment so you kind of know how far down that is. And your slope there is -1 minus 0 over 3 minus 1, -1/2. So that means your y value right here, that height, is a -1/2. And remember that integrals are signed area. So you are left with a -1/4, okay? If it said to find the area, obviously area is always positive. But when you're being asked to evaluate an integral, it's signed area. So g of -2, that means we're going from 1 to -2 of f of t dt. So let's look at our picture here. 1 to -2. So that's all of that, okay? Not including that first triangle we just did. And it won't let me erase it. So let me go over that with blue. So this is going to be the blue shaded region. Okay, so you can see you have a triangle and a semicircle. Notice that your integral does go from largest to smallest, so right away we can flip that. And your area of your triangle, your base is 1, your height is 3. So it's going to be 1/2 times 1 times 3 plus the area of the semicircle, which is underneath. So that's actually going to count as a negative. So let's change that to a minus. 1/2 pi r squared, where your radius is 1. Okay, and then we're just going to simplify that, which gives us a -3 over 2 plus pi over 2. So that's all they're asking in part A. For part B, it says for each of g prime of -3 and g double prime of -3, find the value or state that it does not exist. So again, g equals the integral of f of t. So g is the antiderivative of our function f, which means f is our derivative of our function g. Okay, so looking at part B, when we're asked to find g of -3 or g prime of -3, f is your derivative of g. So you're just evaluating what's your output at -3. Go look at your graph. We're right here. So just find that ordered pair using slope again. Your slope over here has a slope of 1, so that means your output is 2. And then g double prime of -3, that is the derivative at -3. Okay, so let's go back up to -3. What's our rate of change at -3? That's a line. It's constant, right? So no matter where you pick, whatever point on that line, the derivative is going to be whatever your slope is. And your slope is rise over run, which is up 1 over 1, up 1 over 1. All right, part C is asking for the x-coordinate of each point. So it says find the x-coordinate of each point at which the graph of G has a horizontal tangent line. For each of these points, determine whether G has a relative min, relative max, or neither a minimum nor a maximum at the point. Justify your answer. So our goal is to find when G has a relative max or min or neither, okay? So what we want to look out for here is, where does G have a horizontal tangent line? So when is f of x equal to 0? So that's going to be, because remember, f is our derivative of G. So notice f is 0 at -1 and +1. So that's what we're going to start with. So we'll say the graph of G has horizontal tangent lines when G prime of x, which equals f of x, equals 0. And that happens at x equals -1 and 1. So we're going to justify our answer. I'm going to use my number line. And this is labeled G prime of x. So looking at your graph, notice at -1, it goes from positive to negative, and at +1, it goes from negative to negative. Okay, so let's label that there. So positive to negative and negative to negative. So what is that telling us? It's saying at x equals -1, G has a relative max because G prime changes from positive to negative. And then at x equals 1, G doesn't have a relative max or relative min, since G prime doesn't change sign at x equals 1. All right, and then part D says for -4 to 3, so that's over this entire graph of f, find all values of x for which the graph of G has a point of inflection. Explain your reasoning, okay? So remember when our possible points of inflection happen? So our possible points of inflection happen when our second derivative equals 0 or undefined. Okay, and for it to actually be a point of inflection, we need to see it change sign, because remember what a point of inflection is. It's where your graph changes from concave up to concave down. And using your second derivative, remember when your second derivative is positive, it's concave up. When your second derivative is negative, it is concave down. Okay, so let's look here. So we're looking for where does our g double prime of x equal 0 or undefined. So that means the derivative of f. So when looking at this graph, where is your derivative of this function f? Because remember, that is your g prime. Where is that, or where does this function have a slope of 0 or undefined? Okay, so undefined here, because that's our sharp turn, right? Here it's 0, because you would have a horizontal tangent line. And then at 1 again, sharp turn. Okay, so those will be our possible points of inflection. So when we go to put that on our number line, we'll have -2, 0, and 1. And we need to see is our sign changing from positive to negative or negative to positive. Okay, so let's go back to our picture. Sorry for all the zooming in and out. Notice the slope of this goes from positive to negative, so that's good. Here, it's going from negative to positive, and then there again it goes positive to negative. Okay, so we can fill that in on our number line. So I'm just looking at the slope of f, because the slope of f is our second derivative of g. Okay, so like we said, it's going from positive to negative, negative to positive, and then positive to negative. So our point of inflections will happen when x equals -2, 0, and 1, because g double prime of x changes sign there. All right, and that's question 3.